Okay, our next speaker will be Madlen Margau from the Center of Forensic Sciences in Toronto, Canada. And she's going to be speaking on the analysis of black electrical tape as forensic evidence.
Good afternoon, everyone. So I'll be speaking about the analysis of black electrical tape today. This work was interpreted by myself and Jerry Lynn Vardy at the Center of Forensic Sciences. This is a lab that services the province of Ontario in Canada, and Ontario is the second largest province with a population of 13 million people. We have two laboratories, one in Toronto and a smaller lab in Sault Ste. Marie that services the northern part of the province. By talking about an example where we encountered black electrical tape as evidence, and this is what began our study of the electrical tapes. I'll talk about how we do electrical tape analysis and characterization using physical properties and the chemical and determination of the chemical composition using the standard techniques available to us in our laboratory: Fourier transform infrared spectroscopy, pyrolysis gas chromatography, mass spectrometry, scanning electron microscopy, energy dispersive X-ray analysis, and X-ray diffraction. And lastly, I'm going to talk about some preliminary work looking at electrical tape backings by laser ablation inductively coupled plasma mass spectrometry. In August 2007, there were 3 bombs either sent or delivered to, at the time it seemed like 3 random people, random unrelated people. It turned out that these 3 people, according to Adele Arnaud, who was the person who sent the bombs, had wronged him in some way. One person was a previous roommate. One person was a handyman that had also who had evicted Adele Arnaud, and one was a lawyer who had represented him in a criminal charge in a previous case. In this case, we had looked at, there was several pieces of evidence submitted to the Center for analysis, including multiple types of tape. The electrical tape from the 3 bombs sent were compared back to a roll of tape at Arnaud's residence. And these provided a link. The tape from the bombs were indistinguishable in physical properties and chemical composition to the roll of tape at Arnaud's residence. One of the questions that came up in the preliminary hearing in this case was our ability to distinguish between black electrical tapes. And this is when we decided to do a study of our own to see how much discrimination we can get. And I do want to mention some recent studies that have been published. One by the FBI, where they found that they could discriminate. They had an 85% discrimination based on the adhesives of electrical tapes alone, with further discrimination looking at their backings. And Goodpaster has published studies looking at the discrimination based on surface features, SEM, EDX, and FTIR. And one of the questions is, are studies done in other countries relevant to the tapes that we have available to us in Ontario? The way we do our electrical tape analysis is we start with the physical properties. We'll do microscopy, we'll look at surface texture, we'll measure width and thickness. We do FTIR on the adhesives, backings, and we extract the plasticizers from the adhesives using a solvent, and we'll analyze that as well. We look at the adhesives and plasticizers using PGC-MS. For this study, we didn't look at the backings, but we would in casework. We did XRD of the backing side of the tapes, and we looked at SEM EDX of both the adhesive and the backing. In casework, we would look at physical properties first. In our case, due to the large number of comparisons, we looked at physical properties last. We collected 78 tapes. We went out to hardware stores, discount stores, electrical stores, and we also got tapes donated from households. And we went, some of the stores, we went to multiple locations, and we purchased every type of electrical tape they had. We analyzed and compared these tapes. We first grouped them by chemical properties and then by physical properties. Where were these tapes manufactured? The largest group was manufactured in Taiwan, and there are 3 manufacturers divided into 10 brands. One manufacturer in the United States, Scotch 3M. We had 16 tapes in 4 brands, and at least 3 manufacturers in China. Not all the manufacturers were listed on the tapes from China. And there were 14 tapes in 9 brands. And then there's 1 tape where we did not have the manufacturer's information, but that particular tape we were able to distinguish from all the others. One thing to note is none of these tapes were manufactured in China, which does indicate to us that it is an international market, and the results of other studies would be relevant to the tapes that are available to us. I'll first go through the different techniques, and then at the end I'll go through the results that we obtained. So for the polyvinyl chloride-backed tapes, they were first divided into tapes with clear adhesives and black adhesives. The adhesives were generally butadiene isoprene styrene, and they had a combination of fillers, calcite, origonite, a combination of the 2, or none seen by IR. And they also had, plasticizers, either phthalates, adipates. 2 samples had phosphate esters, and some of the samples had mixtures. The black adhesives, due to the high loading of carbon black, it was difficult to identify the type of adhesive, but we were later able to identify the adhesives using pyrolysis gas chromatography, and most of these, all of these had adipate plasticizers. 4 of the samples that we had, and these were manufactured in 3M, had rubber-backed adhesives. Were rubber-backed tapes, not PVC-backed tapes. These ones had clear adhesives that were acrylic and talc in the backing. We were not able to further discriminate these 4 tapes chemically. 1 tape had a different width, so I'm going to focus my discussion on the PVC tapes. And here's an example to show you 2 spectra of 2 tapes that we were able to put in, that we discriminated against. So you could see in the area that's circled in the red, there's a peak at 1539 that's present in the top spectra and not in the bottom. And then there's a doublet at around 1370 that's present at the bottom, in the bottom spectra, and there's only a singlet in the top spectra, and that's from the tachyphyre. Using PGCMS, we were able to, for the clear adhesives, we saw that we had butadiene isoprene styrene, and we also saw small amounts of an acrylic component, which we did not see by IR. And it gave us more information about the plasticizers that were present, namely the minor components, again, that we weren't always able to see by IR. For the black adhesives, we were able to determine what those were, butadiene isoprene styrene and butadiene styrene with a polyterpene tachyfire. And the plasticizers, again, it gave us more information about the minor components that were present with the adipates. And here are two chromatograms, and you could see, again, these were two tapes that we differentiated. The top one has more isoprene as compared to butadiene, and the bottom one has more butadiene as compared to the isoprene. The top chromatogram also has the acrylic component, methyl methacrylate, and they both have styrene, D-limonene, and a phthalate plasticizer. X-ray diffraction for the tapes with the clear adhesives, we saw antimony oxide, which is a flame retardant. It was present in some of the tapes, and then we saw a combination of the fillers, so calcite and aragonite forms of calcium carbonate, rutile anatase forms of titanium dioxide and talc. And for the tapes with the black adhesives, we saw antimony oxide in all of the tapes and calcite in some. And here are two diffraction patterns. The top one has more antimony oxide compared to calcite, and the bottom one has more calcite compared to antimony oxide. So these both have the same components, but they're present in different amounts. The surface features we could see using scanning electron microscopy. The surface features are present on the tapes from the manufacturing process as well as from the pigment size of the fillers that may have been added to the backings. The tape on your left is less rough, and the tape on the right has more features as well as the oval pits, which are present from the manufacturing process or calendaring marks. Energy dispersive X-ray analysis. For the clear back tapes, we had a combination of different elements present in these tapes, and this data is just for the backings, but we did look at EDX of the adhesives as well. And I just listed the main elements present. Some of the minor ones are not listed here, so you could see there's a lot of variability. And the backings of the black adhesives had less variability in the elements present. These are photomicrographs taken through a video camera on the laser ablation ICP-MS, and you could just see the features of the backings and how they vary. So the top two tapes have calendaring marks, and then the bottom two tapes have different amounts of surface roughness. Our results for the 78 electrical tapes analyzed, which represents 3,003 pairs, we first grouped those tapes into 10 groups according to FTIR. We then compared each of the tapes within those 10 groups, and we looked at the PGCMS results for the tapes within each of those 10 groups. And we were able to further break those 10 groups down into 15 groups. We then looked at each of the tapes in those 15 groups, and we looked at the XRD results of those groups, and we were able to further break those 15 groups down into 33 groups. And then we looked at the elemental composition from SEM EDX of each of the 33 groups, and we're able to break that down into another 36 groups. So that's for the chemical composition. And then lastly, we looked at the physical properties, microscopy, thickness and width, and we were able to further separate those 36 groups into 48 groups. So that, our overall results, we were able to discriminate 2,955 of the 3,003 pairs, which gives us a 98% discrimination. How does that relate back to the brands? We're able to discriminate all the tapes from the different manufacturers. We're distinguished all but 3 pairs of tapes from different brands. Distinguish some tapes of the same brand, and one tape out of 6 tapes in a multi-pack. And this multi-pack was a rainbow multi-pack of 10 tapes, which had another 4 colored tapes. So we were able to distinguish one of the, there were 6 black tapes within this multi-pack, and we were able to distinguish one of those black tapes from the other 5. And how does this relate back to the specific brands? So our largest group manufactured in Taiwan. There were 37 tapes manufactured at Atovac company. That was broken down into 22 groups, and they were that had between 1 and 5 tapes. The ones in blue are the multi-packs, and then there was Cantech, one group that had Cantech and Tartan 3M tapes, which we were not able to discriminate from each other. Then Akeem Technology Corporation, we were able to divide those 8 tapes into 5 groups, and we were able to distinguish the tapes from New Age Supply Company. From the tapes manufactured in the USA, the 12 PVC tapes were broken down into 5 groups. We were able to distinguish some of the same brands, and then the 4 tapes that had the rubber backing, we were able to break down into 2 groups. And our last country, tapes manufactured in China, Ibai Huxia. There was one group that had home electric and T4 Proflex tapes that we were not able to distinguish from each other, but we were able to distinguish other T4 Proflex tapes and home electric tapes. And then we were able to distinguish the rest of the tapes manufactured in China. And then there was the one unknown tape that we didn't have manufacturer's information for. So I'm going to spend the last bit of my talk talking about the elemental composition from laser ablation inductively coupled plasma mass spectrometry. So this is a technique that allows the determination of elemental composition at the ppm levels of multiple elements. And again, this is preliminary work that we've done. So we analyzed 8 elements, 2 isotopes of 8 elements, and 2 of those elements we looked at 2 isotopes for lead and antimony. We did a raster scan over a 1 by 1 millimeter area of the PVC backing. And for our preliminary data analysis, we used a criteria of plus or minus 40%. We analyzed 54 of the 78 electrical tapes, and that represents a 1,431 pairwise comparisons. And we did some initial reproducibility studies. So for a number of tapes, we did repeat measurements. For one particular tape, we looked at 17 samples from that tape. And when we applied the plus or minus 40% criteria, only there were two pairs that were falsely discriminated based on only one element, zinc. We compared the results for the 54 tapes. The titanium was able to give discrimination of 91% of the tapes, aluminum 90%, magnesium, calcium, and lead 87%, zinc 83%, antimony 77 to 78%, and barium was 64%. Overall, we had a 99.4% discrimination based on the electrical tape backings. we wanted to see how this related to our groups of tapes that we were not able to distinguish using other techniques. So we had 12 groups of tapes that were indistinguishable by the previous techniques. Once we did laser ablation ICP-MS on those tapes, and some of which were multi-packed, same brand and different brand, we were able to further discriminate 8 groups, and we were left with 4 indistinguishable groups. 3 of those groups were multi-packs, and 1 was of the same brand. The result that surprised us the most was discriminating the multi-pack of 4 tapes. And again, that multi-pack of 4 tapes was part of a rainbow pack that had 6 color tapes in that pack. So I'm not sure how that rainbow pack was assembled and whether those 4 tapes were actually from the same batch or not. Most of these discriminations were done based on more than 1 element. 2 of the pairs were discriminated based only on 1 element. The preliminary results look very promising. A lot more work needs to be done on the interpretation and to ensure we don't have any false inclusions or false discriminations. So really looking at more reproducibility studies. I would like to thank NIJA and FBI for holding this conference and for sponsoring my attendance. This project was started by an undergraduate student, Chu Jen Wei, at the University of Toronto. I'd like to thank the Center of Forensic Sciences for supporting research, and then a number of people that were involved in obtaining the data and helping interpret the data. And thank you.